Now, before we get into Rutherford's experiment, it's important to understand nucleic notation. Now, if you've done chemistry or you are doing chemistry, I'm hoping that you know how to use the periodic table. So, here's an example of helium as it would be represented in the periodic table. The top number is known as the mass number or nucleon number. What that basically represents is the number of protons and neutrons inside the nucleus. So here we have 4 nucleons. The bottom number here represents proton number or atomic number. This represents the number of protons, and in a neutral atom would also represent the number of electrons. So here the helium atom has 2 protons, 2 electrons. I can tell that from the bottom atomic number or proton number. And it has 2 neutrons because the nucleon number is neutrons plus protons. Therefore, the number of neutrons is the mass number minus the atomic number because we already know the number of protons. So, here is our Nuclide symbol or Nuclide notation for helium. As already mentioned, nucleon number A at the top, number of protons plus number of neutrons, proton number or atomic number at the bottom, often represented by the letter Z, which is basically the number of protons and happens to be the number of electrons in a neutral atom. Neutrons equals nucleon number minus proton number. Isotopes. What is an isotope? Well, I hope you understand from chemistry, an isotope is an atom with the same number of protons, but a different number of neutrons. In other words, it has the same atomic number, but different mass number. Here we have 3 isotopes of oxygen. And if you look, we have the same proton number for each, 8 in all of them. And if it was a neutral atom, we would also have the same number of electrons. So they would also have 8 each. However, what is changing is the number of neutrons from one isotope to the next. If you remember the last slide, the number of neutrons is the nucleon number or mass number, which is at the top, minus the proton number or the atomic number. So 16 minus 8 gives us 8 neutrons, 17 minus 8 gives us 9 neutrons, and 18 minus 8 gives us 10 neutrons. So the atomic number is the same, but the nucleon number or neutron number is different. Because they all have the same number of electrons, isotopes have identical chemical properties. Because they have different numbers of neutrons, isotopes have different densities. Some isotopes have an unstable nucleus, so they are deemed radioactive.